Allora, buonasera, vediamo se funziona. Sì, ok. Buonasera, buonasera. Ci siete? Dai, fate un po' di casino, dai. È finita l'estate e siamo ancora qua a sviluppare C++. Per quanti anni ancora non lo sappiamo, però per il momento ci godiamo ancora che non siamo stati rimpiazzati dall'AI. Ok, quindi è già qualcosa. Allora, poi potrebbe arrivare anche Rust effettivamente, ma quella è un'altra storia. Dobbiamo combattere contro diversi nemici. Allora, scherzi a parte, vi do il benvenuto in questa splendida location che era, credo, la terza volta che siamo qua. Quindi vorrei fare un ringraziamento speciale a Microsoft, in particolare a Roberto Filippelli, Matteo Pagani. Quindi chiederei di farvi fare un saluto se avete piacere.
Oltretutto sono nato come programmatore C++.
Ah, beh, allora quasi questo qua è un colpo di scena incredibile.
È un colpo di scena e il vero dramma è che dovevo lavorare con dei programmatori Twitter. Però la cosa bella è che implementando gli operatori del C++, quei due programmatori pensavano ancora l'ora di programmare in Twitter. Quindi io sono un vero fan del C++, secondo me non sparirà perché la potenza del quel linguaggio è fantastico. Devo dire, C++ è una cosa complessa, serve sempre in una country come l'Italia che ha tanto manufacturing, ragazzi, quando si devono fare le cose serie si fanno C++ o in C, quindi io penso che questo modo di sviluppo durerà ancora per tanto.
Grazie.
Prego.
Applauso. Allora, oltre a ringraziare Microsoft per offrirci questa meravigliosa location, dobbiamo fare un ringraziamento speciale ad Hermit, che è l'azienda che ha sponsorizzato questo evento e ci ha permesso di essere qui. Quindi vorrei invitare Emanuele Baldini, fate un grande applauso. Ottimo. Adesso facciamo uno switch di presentazioni. Vediamo. Si vede già così o...
Su screen riesci a metterlo?
So, this is my first talk, so I'm a bit nervous, but let's see if I can do it. So this evening, thank you for being here, and I'm going to talk about assertion, contracts, and what can we do to write correct code. So, words about me. So I'm an old programmer. I worked in C++ for so many years. I started before C++ 98, so quite senior. And I've been exposed to a number of languages and work mainly in the embedded system. Also, I worked on several different industries. Well, video games is good to break the ice at parties. Okay, this is more or less the agenda. I will give you the motivation for this talk. Then I introduce assertion contracts, what kind of type checks we can do to compile time, present the concept of refined types. Then I have a look at the GSL library, and then the limitation for the proposed solution and conclusion. So why I'm quite introvert, so it's quite difficult to be here. So why I'm here? So I wrote some articles for embedded related website. It's a good website to find good articles about embedded systems, embedded programming. And I wrote some articles, one on the state machine, and the other one on the assertion, the topic of this evening. And I found that the state machine got about 5 times the number of views about the other one. And I say, why? You can learn about finite machine almost everywhere. It's not something that is rocket science. I mean, yes, interesting. I think I wrote good text, but okay, you can find that everywhere. Why assertion and writing correct code is something that is harder to be taught at school or to find around. So I said, no, I have to do something. I have to convince people that this is an important topic. Writing good software is important. So let's talk about assertions. So, well, assertions actually were invented in 1947, which was the very dawn of the computer science. And computers were 230 square meters of stuff, of relays clicking, and they can achieve the incredible speed of 8 multiplication per second. So, and people were trying to find ways to design the programs, to plan how to write code and so on. So it was very important that if the program wasn't going to give a good result, the expected result, then it was important to stop it as soon as possible. And so in the flowchart, they invented this box. It was the assertion. Of course, unit test was beyond any wild imagination, and they had this idea, let's put some blocks to verify our expectation. So if at a given point of the flowchart, we need this number to be positive, then put this block to check if it is positive. If it is not, then we have a bug, and better to stop and check the code and start again. So, okay, so this is a C++ example. Okay, the assertion, the classical example, square root for real numbers wants a positive or 0 argument. So if we give something negative, it's a bug. Okay, and so we put, I think there is a pointer. Yeah. Okay. Well, anyway, the assertion is there. Okay, if someone calls the square root function with a negative number, the assertion triggers and the condition fails and the program is halted. So in C, assertions are implemented as macros, so they are not part of the language. And as in the tradition, when the expression is false, so the condition fails, the program is terminated. And you can switch off this behavior by defining this end debug, so everything in the preprocessor, everything very C, very C. So, but since they are macros, when you disable them, everything that is in the parentheses is not compiled, so it's not evaluated. And if you have them, there are some side effects, so call to function or expression that changes the global state of the program. These are no longer executed. So there are many problems. I pointed to 3 about the assertion. So is it actually okay to disable the assertion? These are 2 different schools of thoughts. One say yes, they have to be disabled for released software, and the other one that say no, you tested with the assertion enabled, so you need to keep them in the release. So the NASA is, I don't know if this quote is real or not, but I think it's proper. So fly what you test and test what you fly. Indeed, it is true that if you have a code that is sensitive to timings and you check condition that takes time, so removing the assertion may cause some time shift and the program may not work. Not very reliable, but if it's made to release, then maybe you want to keep that. Okay. Yes, also this example. Okay, I put a function that does something that loads firmware or whatever. So something that has an effect on the system. And this is bad practice actually, but you can't prevent them from happening. So you have to manually review the code to avoid this kind of problem. And okay, the second problem is that okay, actually the failed assertion causes the problem to okay, you don't have any way to prevent this, but disabling entirely the assertion. So yes, indeed, they are taught to check internal condition to find bugs, but again, they can be misused to validate the inputs or validate the incoming data. And so this is an error, a misuse of the tool, but again, you can't really prevent this misuse. So, for example, this is another example, don't do this at home. You want to check that binary data are not present in the stream, so you check that is either a control or printable character. Okay. This is wrong because I can't, okay, the input can be everything, and it's not a bug, it's the user that types something that I don't expect. So I have to validate first and then process the data. Okay, the third and worst problem is that the assertion catches the problem at the worst possible time. So during the runtime, the system is on service, is operating, is doing its work, and then it stops. And this is actually not good. I would like the problem to be caught in advance. And when I find that a session is failed, I know that someone in the system used my function in the wrong way, but I don't know who has been to use it. I don't know where the bug is. I just know that somewhere there is something that doesn't work as I designed it. Okay. Yes, you can somewhat mitigate this by stuffing the code with assertion everywhere, and you get closer to the source of the problem, but it's quite expensive solution, and eventually you don't get to the source. So C++, starting from C++ 26, will implement the contracts that are a revamp of the assertions. So about contracts, yes, they are not a new concept. They were invented back in 1986, and C++ introduced them. We introduced them. Yes, I'm not a time traveler. I just had that time. So we introduced in C++ 26, and they are not yet implemented in any major compiler. So there is. Yes, there is some branch you can try, but not in the ministry. And also I found quite hard to find tutorial and usable information. There is the proposal and also the chatbot are not trained yet on this part, so you could get some odd response from them. So, what are the contracts? Yes, basically they are a specialization of the assertion, but basically the idea is that I want to put in the code the constraint on the interface. So what I usually write in the documentation, so I want this function with positive arguments or less than or whatever, I want to write them in code so that the execution can check for this constraint. And there are basically two constructors that are precondition and post-condition. So precondition basically check the input of the function, so they are checked before the function body is executed. And post-condition that checks the output. So you may want to check the output. Then I have an example that better clarify this. And post-condition, of course, are evaluated at the end of the execution of the body of the function before the return. before returning to the code. And yes, the idea is of contract as violation of contracts causes the termination of the program. So this is the example of a C++ 26 precondition. Quite simple, but yes, things can get complicated. So right after the signature of the function, I put pre, which is a keyword, and followed by an expression that needs to be a valid expression. This is not very different from the assert example we saw earlier. Okay, that's an example of precondition. And okay, we also have postcondition. Yeah, the main problem of the postcondition is how do I represent the result? So here I'm returning a variable which is result, and how should I reference? So there is that simply you put a colon, any symbol you want, followed by a colon, and then the expression. So the R in the post expression is actually assigned to result. And there are 4 types. So the C assert, yes?
Which value of X do you use? Changes during the
Yes.
You put a constant.
Thank you. I missed this part. So actually, when you put a post condition that references the argument, you need to declare the argument as const, because basically otherwise you could change the X value in the execution. And so it would be ambiguous, this expression, which X values. So by declaring const, you declare that X won't change in the body of the function. And so you have no doubt which X will be checked here.
So it's like if you get it by reference.
Sorry?
It's like if you get it by reference in a number. So if it changes during the code, you get the value of X. The value of X enter into instruction.
Yeah. Yeah. Yes, you can have a reference also, but it's, okay. It's actually in this presentation the examples are quite simple, straightforward, but actually the proposal for contracts is very complex because there are a lot of corner cases, special conditions, so that are properly designed in the proposal. But it was a bit overkill for this presentation. Okay, so contracts. We have basically 4 evaluation strategies for the expression put in the post condition precondition that are ignore, observe, enforce, and quick repeat false. So ignore is nothing happens. If the condition is false, then nothing happens. Everything continues as it would be true. Observe, so it's like defining end debug for the C assert macros, with the difference that with end debug, what is in the assert argument can be anything, so even not C, not C++, while since the contracts are part of the language, even if you ignore, they should be well-defined expressions, so they have to be C++ expression. Observe is the evaluation strategy that when the expression is false, calls an handler, and failed contract handler, and then terminates the execution. Sorry. Okay, observe is just observation, so it calls the termination of the contract handler, the failed contract handler, and then continue the execution. Enforce instead is for termination, And quick enforce is just termination without calling the handler. So there is this handler, I explain it in a moment. And so these are very flexible mechanism to decide and to set what we want the behavior or filed contracts to be. And the selection, it is implementation defined, so it's not defined by the language itself. Every compiler, every vendor could decide how to do it. And the interesting part is that you don't need a global strategy. Every completion unit or even every function can have a different strategy, but it depends on how the vendor implements this setting. Okay, go to the handler. There is this handler contract violation handler, so it's a function that is called when the strategy is either observe or enforce, and the precondition fail. So it's implementation defined what this function does, and it is implementation defined whether you can override, so you put your code there or not. And as I said, there are really zillions of details, so how to do this for Lambda, for context, what happens when an exception is thrown, and so on. So if you are interested, I suggest to read the proposal. It's very okay. So does the contract solve the problem we had with assertion? Well, yes, we can be disabled. So it's not clear about the side effect, but if you disable the side effect, are not executed. So really not solved. Termination. So yes, this is somewhat yes, this is wrong. It's partial solved, but you have some degree of flexibility, so you can keep the program working or make it fail according to your design. And while the runtime check, yes, this is not solved still, are enforced at runtime. So closing conclusion on the contracts. So they are model assertions. So if you have to choose between assert and contracts, of course, go for the contracts. They are better defined, they are customizable, and well integrated into the language. They are not macros. Yeah. So the idea is that contracts and assertion are basically a safety net for when a bug happens. So you want to prevent that something goes really wrong. So they terminate the program, and that's it. So, but what kind of alternatives we have for checking the requirements for function interfaces? So, a bit of excursus. So I spent about 4 years with the functional programmers, and yet there are quite a bunch of people and very opinionated. Well, I'm opinionated too, but with clear ideas on how to write programs, how to call stuff, and what is right, what is wrong. So, and they have several interesting concepts. One of the most interesting is this, is make invalid state unrepresentable. So write the code so that invalid state cannot be represented. So if the state, the invalid state cannot be represented, I don't have to check for validity. So I can't misuse something. I don't have to make stuff in a given order to get validation and then execution. So, and this is basically not very far from the RAII. So resource acquisition is initialization. You want that after the constructor, the object is complete. It doesn't have to be valid, make it valid in some way. So yeah, no need for the isValid method. And another interesting point from my functional programmer's friend was about typing. So they were very strict on types. At least I think that those who write typed functional programming language. So because types are actually checked at compile time, and they prevent you from sending the wrong type to a function. You can't pass an integer to a function that expects a string. But this is something that it's very close to the problem we want to solve. So we could define types so that they carry around properties for the container value. And this concept is defined or smart types. Possibly there is a difference between the two, but for me are quite equivalent. So let's define types so that they bring around the properties of the container data. And the classical example is an email address. So yes, we can use a string, but not every string is a valid email address. And yeah, so we can define a type, email address, that only can contain valid email address. Now, if my function wants an email address, can expect an email address type, and I don't have to put assertion, I don't have to check for valid data. Because if the code compiles, then it's for sure it's correct. Okay, so what's the idea? So I have a constructor that has to validate the data. So the constructor prevents the object to be not valid. That is the RII. And okay, you can use constructor. How to do this? You can use constructor with exception or some factory method that returns an optional or expected. Of course, this class shouldn't provide methods that make the content invalid. So the methods should transform if needed, but always producing a valid object of a valid data. And then, well, you can access the underlying type by const getter. Okay, let's compare this with the assertion and comments. So we can disable, well, they can't be disabled. There is a compile time. There is no point in disabling also in when the code is released. So the termination is, what is terminated is the compilation. So it's not a problem, it does not apply. And we check in advance, and check in advance at the point where the data is constructed, so where the bug is happening. Okay. And so little code just to make things a bit more concrete. So I define this email address, the string email is the underlying type implementation, and I define for convenience the static boolean is an email that gets a string and returns true if it's true or false if not. Yes, these are options. And so the constructor is explicit, of course, because I want to construct explicitly the email. I give it a string, and then if it's not valid, then I throw an exception. So this way I prevent an invalid object to be used. And okay, this is the getter, so I could retrieve the underlying string if I have to pass to somewhere or to print it or whatever. So I can do the same using the optional, so just to have a look at how things are changing. So the constructor is went to the private section, and I have a make static method that gets the the string, and if it is valid, then calls the constructor. If it's not valid, the optional is empty. So using smart type is quite straightforward. So instead of having my function that wants a string when I need an email, I use the email address to receive the email. So how do you use them? So of course, these data are coming somewhere from a database, from the user input or whatever. So at one point, at the periphery of my system, I will construct the smart types. So I have a process input that actually construct the smart type, and if it's not, then I know that the input I receive some garbage for input. I have to prompt an error or whatever. I can recover or not from the program there. And then the inner parts of the code just uses smart types. Okay, so I found this very, very interesting, very powerful. So from grid powers, let's see what kind of problems we can solve. And I decided to try the $1 billion mistake. This is what is the null pointer. So Tony Ware worked in 1965 at Algol W. He's the inventor of the null pointer, so he was implementing a type system, and that had to be correct and so on, but he was tempted to put this null pointer because it was very easy to put there. And since there, he called himself, so it's not declaring his mistake, but himself is calling this the $1 million mistake. This is the presentation. Then you will have the presentation, so this link you can find this. And okay, well, maybe you think that having null pointers is good or no, so it's not the topic of this talk, but for sure, as a C and C++ programmer, it happens that you try to dereference a null pointer, so it's something that life would be better without, at least in the moment. So, but yeah, so when I was preparing this talk, I remember that there was a type in the GSL for not null pointers. GSL is the core guideline support library. So core guidelines are an effort from Stroop and the other C++ gurus to write a set of guidelines for writing good C++. And in doing this, they designed and developed this GSL library. It is for guideline support library. And inside this library, there is also this type, so GSL not null pointer. And so let's check it out if this can be used, so I don't have to write anything. We solve the $1 million problem. So this is, you include the GSL pointers, and then I put a random function that wants a pointer and the reference assigning 3, for example. And I call it with null pointer. So I try to compile, and properly I get the error. This is it's wrong, okay, but it's very long error. But apart from the error, properly the library worked and prevented me to pass a pointer where it was not expected. Good pass. And but let's try to change things a bit, and don't use null pointer directly as an argument, but assign first to a variable and then pass the value. So the semantic is the same of the previous example, but the syntax is slightly different. Try to compile this, and this is compiled. So not good. So let's try to execute it. And yeah, basically the program is terminated. So what I expect is that it behaves like an assert. So the GSL not null partially solves the problem. So if you have a literal assignment, then it is able to detect it and to give you an error at compile time. But if you go around and don't use literals, then it's not catching the problem. So it's an assertion in disguise. So let's roll our own solution. Okay. This is basically a proof of concept. Of course, C++ expert will have to argue about reference templates and so on, but just keep it simple for understanding what's going on. And so it's not different from the email example. We have the underline type in the private section, and we have the private constructor. Okay. And we have the static method. So static method. If the pointer is not null, then we return the object in the optional, otherwise the empty optional. And then it's mostly done. We have a bunch of operators we want. For example, the referencing is very simple. But some operators need to have a special care, because we don't want to have somehow null pointers. So, for example, if the plus operator, I pass this ugly expression, it will produce a null pointer. This is why I declared the plus operator as standard optional. So if this is going to produce an invalid pointer, then I will have the null, the empty optional. And so, yeah, so some operators are really straightforward, some need some care, but there are a couple of operators that cannot be implemented. So the plus equals and minus equal cannot be implemented because they are changing the instance on which they are called. And they could actually accidentally make the instance null pointer, so they cannot be yes, here you can find the proof of concept implementation complete for the pointer. So, good. So smart pointers are always good. Well, yes and no. So they're static, they're enforced at compile time, so they work with static properties. So valid email and pointer, but if I have a dynamic properties, for example, consider a timer, and I want to design a function that wants only non-expired timers, okay, I can't code these with smart pointers. I have to do something else, because the timer object, the expiration is something that happens dynamically at runtime. I can't define a time for it. And also the dynamic relation. So if you remember the contracts, we could put a post condition that basically enforces the dynamic relation between the argument and the result. Okay. Also, this is something that happens at runtime and depends on the input. And again, I can't use the smart types. And yes, if I take the function approach of having immutable values, so everything constant, then smart types works better applied. Okay, and then there are some limitations, of course. This is C++, the programmers always know what it's doing. And so if I mem set the object, then there is nothing I can do with types. It will be clear that I will get a new pointer despite of everything. And the other not so obvious problem is that radiation. So I work in the space industries, and this is actually a problem. So an alpha particle could hit my lines or my transistor, and actually what used to be a 0 becomes a 1, or vice versa. And it happens randomly. So even in this case, something that happens at runtime, and my type doesn't give any enforcement of my requirement. And it is true that being this C++ and being a fine grade of detail where you can put code across the operation with operators and with overloading, you can add assertion inside the smart type. So before using the pointer that is expected to be not null by the type, you can also add an assertion that won't be triggered, but at least your satellite, when is hit by an alpha particle, won't stop working. So,
You have time.
okay. So, conclusion. Well, the assertion basically implemented the design by contract. And design by contract, we have seen that enforces contract at the worst possible time. It's good for a safety net, but it's not very friendly for released software. And yeah, the alternative we found is to define types so that we cannot represent invalid state in our code. This is checked at compile time, and so the contracts are satisfied by completion. It's proved. And we're saying this can be applied almost everywhere, but there are some cases, for example, dynamic properties and alpha particles that make it impractical to be applied everywhere. And that's good.
Question.
Two questions actually. First one, your proposal reminded me of a library that I saw from Jonathan Funatan on GitHub. TypeSafe, TypeSafe, it's called, and it wraps a lot of stuff like integers, pointers, etc. Have you looked at it? Did you know it exists?
No, actually, no.
But
I
you might-
will look it up.
You might want to
but
take a look.
Also, I read that Matt Godbolt, the compiler explorer, had a talk recently where he exposed something like this for better typing of the function interfaces. So it's, well, I don't claim to invent all this. I just be influenced by functional programmers.
Yeah. I was just asking because in the end it's a problem everybody has more or less.
Yeah, sure.
The second question is, your proposal looked to me more like instead of putting assertions everywhere or checks, say merging them to just one point, like because your function requires a specific type that you know for sure is going to be, let's say, valid, but somewhere you have to do an if check to know if the type is valid or not.
Yes.
So it's like an aggregation, let's say, of assertions.
Yeah. Basically, ideally, you have the outer bounds of your software, the bounds that interacts with the outer world, that has to do validation. Okay. And so there will be a lot of checking, trying to construct valid types and going on in the execution only if the input is valid. And then inside, in the core of your code, you can rely and avoid checking almost always. But for the case where you try to either to mutate the object or to do some computation on that, that may result in something that is not suitable for further elaboration.
Okay. Thanks.
Other questions? Always you in the middle.
The GSL library has an asset module which defines two, if I remember correctly, two macros, expect and ensure, which I think they are slightly better asset macros. Do you think that is a good approach, or what do you think about it?
I don't know really well the GSI libraries. I just remember this type. So I think that there are something provisional waiting for the C++ 26. So I think that being designed and imagined by Strustrup and the other C++ guru is surely something to consider with attention, and why not? Also because using assertion, naked assertion, let's call them, is something that is not very convenient for the size of the programs we have today. For sure, you want to override, to have a handle, to do something to implement the concept of assertion. So if you have something that is already made with these properties and it fits in your project, then for sure it's something worth evaluating.
Okay, just a curiosity. This is the first time I see that there is C26. And regarding the contract, when the slide showed the definition of the function, so I was asking myself if the definition of the prototype could at least solve the problem of pinpointing the error in the caller. So if you have the prototype, yeah. Yes, if that is the definition of the function. If I can put a pre inside the .h file, I could also catch the problem inside the caller directly in the line of code where it happens.
I don't think so, because the semantic is defined to check when the function is called. So this is evaluated when the execution code reaches the STRT function and start executing. So this is evaluated.
Oh.
And
so it's not the part of the
caller.
No? Yes, but what I thought, okay, if I know that if the prototype function is that one, before calling, the compiler could also put some check inside that, and the error would be in the caller and not in the called.
Yes, I understand, but
it's not the way it works.
It's not done. And then the proposal, as I said, is quite complex and quite lengthy. So if you are interested in the context, sure, is worth reading.
And the second, since we work in the same company, it's not always possible to use the C++.
Yes.
And the question is, can we use this kind of C++ things inside our code? No, you mean your solution.
The solution.
Because it's
Yes,
a debate lasting many years, but
so
most of the code I've written so far is C, it's not C++.
Yes.
So that is a sort of strong typing that I would like to use, but I don't know if I can use in strictly code that cannot use, C++.
Yes, you actually can. So if you use struct, C has a quite good checking of the types, as long as you don't use void pointers and you don't use enums that are freely mixable with ints. So if you use struct, you can design something like this. The problem with C is that it doesn't allow the writer of the code to put fancies as constraints. So everyone can access the struct and change the type. So I can call my struct email address and put there an array, a character array. But then everyone could access that array and everything. So this is more or less the same concept. You can do object-oriented in C, but you have to follow quite strictly some rules and be sure that no one breaks those rules, and it's quite Zen-like approach. So yes, you can, but it's quite an effort. Also, everyone in the team should agree that that is the good way to do still, not having someone that works other way.
Hello. So I have to do the devil's advocate. I like the solution, but I see a problem. So you mentioned the billion dollar problem, and I see the $1 billion problem exactly in this solution. Because if you return an optional, it's like saying, I return your pointer, and you have always to check if it's now or not. Because if you return an optional, I can always dereference it without checking if it's valid. And in that case, I'm back to square one with null. So basically, what you're suggesting is to implement nullable types that can be null, but then you have to check them every time. And also the other thing that I see problematic is that in these cases, I mean, at least from my experience, the code becomes a bit less readable when you have all these options. So I like the solution. I've done similar things, not exactly this structure, but I see a problem where you have more verbose code, and if not everybody, as you were saying, respect the rules, you end up having the same $1 billion problem.
Yes, sure. The C++ optional indeed has the pointer semantics that it's not very friendly with the example. So maybe the email example is more convenient to make the point. Yeah, sure. The idea is that basically you check first and then you use. When you have the valid object, then you no longer have to check. Yes, optional is more verbose. The alternative is to use exceptions. That is less verbose, but a bit less friendly for large systems. So yes, that's true.
I have a question. Everybody knows that everything has a cost. Okay, so basically my question is, what about the API design cost in terms with contracts compared, for example, with the most simple static assets, for example?
Yes, the cost is a complex topic because how much is the cost of your program crashing in production? Yes, maybe if this is acceptable, then assertion maybe are the simplest and most straightforward things to put there. Having smart types, they are quite straightforward. You could also think about implementing a CRTC template to implement them, and so to have your own rule to validation and make it easy to design and to write new smart types. So yes, it's not as quick as using the types you already have, but it's not so expensive, and it depends also on the production code and the behavior you accept in production. Thank you.
Hello, I have a question about the post condition of the contract. Yes, so this to me looks like let's say lazy way to do a unit test. I don't know. So I mean, is it a good thing to have this lazy way to unit test a function, or maybe do you know? Maybe you saw it in the proposal, like a less trivial example of why a post condition is a good thing to have. instead of making a unit test.
This is the safety net. So you have already done all your unit tests you deem proper to do. But then the code is executing, and the corner case that was not unit tested happens. So this is what saves you in that case. It's not something that replaces unit testing. At the beginning, possibly when the assertions were invented, there was no concept of unit testing. The compute resource was so expensive that they have to optimize everything. So this could have worked also as a way to detect bugs during the development. But for sure, today, I would expect unit tests to be to complete the code.
Other questions? Let's take the last one. Only one? Offers more?
You said that you have a strategy of ignoring failed contract checks, but does the code get executed anyway? So what happens if you have a side effect, it doesn't get executed?
Exactly.
So, yes, that's fine.
Yes. It has to be a valid expression because it is compiled, and so it has to be valid in C++, but it's not executed, so nothing happens.
Other questions? No? Okay, thanks. Thanks a lot. Max was the first one giving a talk in our meetups in English. Because actually I forgot to ask, is there anyone who doesn't speak Italian, who doesn't understand Italian here? Raise your hand. But this is good because the talk is online. So this way, this talk can be watched by the entire world, basically. Yeah, millions of people, literally. So I think this can be the start of a tradition. If you want to give a talk in English, please do it. So it's fine. So thanks a lot again, Max. So people online, bye-bye.